This is it. This is the last part of our systems chapter. This is an algebraic method called solving systems of equations by elimination. Now, before we did these by substituting one equation into the other to get into one equation, right? But now what we're going to do is we're going to eliminate one of the variables. So we're going to get rid of one of them. So how about this? On page 430, it says, let's see, you've got a fundraiser, the Environmental Club, they're selling reusable shopping bags, and they're selling organic fair trade coffee. So two recent sales, they sold 5 bags and 2 packs of coffee. They made 23 bucks, and 3 bags and 2 packs of coffee for $17. Okay, so I could graph these, right? I could try and think about drawing this X and Y axes, and I know I'm going to have like 2 and 5 and X and Y and 23. It's not going to be pretty. Let's not graph it. I could try and solve this by substitution, but I know I'm going to have to be dividing by either 3 or 5 or 2 or 23 or 17. I'm going to be making fractions, right? So let's try and figure these out with 2 equations. I'm going to call B for bags and C for coffee, right? So I know that I've got 5 bags plus 2 packs of coffee is going to equal $23, right? And I also know that 3 bags plus 2 coffees is equal to $17. Now, I know a lot of you would say, big deal. I can actually see the answer right now. The only difference is 2 bags of coffee, right? And the difference here was $6, or sorry, 2 reusable bags. The difference is $6, which means a bag is 3. You're right. The answer is 3. Now, how did we do that? Hang on, let's back that up. What happened here? Okay, so let's see. I've got this equation, it should work, and I've got this equation, it should work. So notice I lined them up like this. I put the equals, I tried to put the equals right on top of the other in the numbers. I'm not going to add these two together. No. I'm going to subtract these two. Because watch. Watch what happens when you subtract. 2c minus 2c, there is no c's. This is 0. What's 23 minus 17? Well, that's 6. And what's 5 b's take away 3 b's? Well, that's 2 b's. So in other words, 2 b's plus 0. I don't need to say the plus 0. 2 b's is equal to 6. That means b is equal to 3. And if b is 3, well, hang on, let's take a look at this, right? Let's just plug it into here. 3 times 3 is 9. 9 plus something is 17. It's 9 plus 8. C's got to equal 4. Ta-da! So in other words, the bags are $3 and the packs of coffees are $4. Done. That was actually pretty quick, and we didn't have to do it by substitution, and we didn't have to graph it. So here's really what we did. We subtracted these two in order to cancel these out, right? These disappeared. Once these disappear, then I can figure out what B is. B is equal to that. Okay. Well, it doesn't work that easy here. If I go add and subtract, no, that's not going to work. So if I simply subtract these two, 4a take away, or 6a take away 4 is 2a's. A's don't disappear. And 5 take away 3 is b. B's don't disappear. So here's what I can do. Let's get rid of these. I'm going to take this one and I'm going to multiply by 2. So in other words, I'm going to multiply everything in this equation by 2. Times 2 times 2 times 2. In other words, this becomes 12a's plus 10b's is equal to 48. Right? I multiplied on 2 on this side, and I multiplied by 2 on this side. Okay, so that's what I did. I've got a similar equation. It just looks bigger, right? This one, I'm not going to multiply by 2. I'm going to multiply this one by 3. Why? Look, I'm going to get 12a's plus 9b's is equal to 36. Okay, so why did I do that? Because notice now, 12a's, 12a's. It's the exact same 12a's. Just like up here, we had 2c's and 2c's. They can cancel each other out and make 0. These can cancel each other out and make 0. Okay, so here's what I'm going to do. I'm going to subtract these two equations. So now I just put a line underneath, and I'm going to go subtract. 12a's take away 12a's, 0a's. 10b's take away 9b's is 1b. And 48 take away 36 is 12. So in other words, 1b, or just b, is equal to 12. Now, I just figured out one of the answers. How do I figure out what a is? Well, see, I went through all this procedure and I got the a's to equate. I got them to be the exact same, so I could subtract and get them to cancel out. I could have done the exact same thing by making 15 B's and 15 B's, right? So I could start over and I could multiply this one by 3 and multiply this one by 5, and that would work. But you know what? Once you've got one answer, just substitute it back in. You could substitute it into this first equation, or I'm going to use the second equation because it has smaller numbers, right? It's easier. So now I'm going to sub back in. Sub back in. So I'm going to substitute my answer back in over here. So hang on. 4a plus 3b is equal to 12. And we just figured out that b is 12. So this is 4a plus 3 times 12 is equal to 12. Or in other words, 4a's plus 36 is 12, minus 36 minus 36. 4a's is negative 24, divide by 4, divide by 4. A is negative 6. Ta-da! There's my A, and there's my B. I've got them both. See, there's one of them, there's the other one. I just figured this one out, and I didn't have to do substitution, and I didn't have to graph it. I'm just going to check it just in case. Now, if I have to do the check, remember, when you're doing the check, you got to check both equations. 6a's plus 5b's is 24. Okay, let's try it. 6a's plus 5b's equals 24. And the other one is 4a's and 3b's is 12. 4a's plus 3b's is equal to 12. Let's try it. A is negative 6, b is 12. So 6 times negative 6 and 5 times 12. So this is negative 36 plus 60, which by the way is 24. Yes, it is. Okay, let's try this one. 4 times negative 6, 3 times 12. So I'm going to get negative 24 plus 36, which is 12, by the way. Yes, it works. So remember, if you're going to do a check, if they ask you to do a check, you have to check it in both equations. So equation number 1, this one, and equation number 2, that one. It's got to work in both. Okay. So in this example, we didn't isolate one variable, but what we did is we combined multiples of the two equations in order to eliminate one of the variables. Okay, so eliminate one of the variables. And you know what? You can choose to get rid of the A's, or you can choose to get rid of the B's. We got rid of the A's just because I saw 6 and 4. Hey, they have a lowest common multiple, an LCM of 12. I can make them both 12, then they'll cancel out. I could have done B's, right? I could have gone 15. So 5 and 3, they both divide into 15, right? So I could have done that one. Now it'll work either way, your choice. Usually one way will probably be easier than the other. Now, here's the reason why. This is an equation. You're told this is equal, right? So if you double both sides, it's still equal. Okay, I'm making a mess out of all this stuff. Let's get rid of that. It's still equal. So you can double both sides and you get another equation, but it's really the exact same equation. Okay, so once you eliminate one of the variables, yeah, and then once you've solved for one variable, well, you can either go through the whole procedure again, but you know what? We know that it's faster just to substitute back in. So substitute back in. So back in for the other variable. For the other, I'm no good at writing with this thing, other variable. Yeah, so once you figure out one, then just plug back in. And you know what? It'll work in any equation. Go for the easiest one. Go for the smallest numbers. It'll make your life easier. Okay, how about this one? It says, Connor downloads games and songs, right? He downloads 5 games, 4 songs, cost him 26 bucks. Then he does 3 games and 2 songs, cost $15. Now the difference is 2 games and 2 songs, and it's $11. It's okay. You know what? Let's make a system out of this. So step 1, let's write 2 equations and then solve by elimination. So we're talking about games and songs, right? So let's call these G and S. So I'm going to say G is equal to the number of games, and S, I hate using S. S's look like 5s. I'm going to say this is the number of songs. Okay, step 1. Let's figure out our 2 equations. So I've got 5 games, and that means plus 4 songs, and this is the total of $26. I know that's an equals, so here we go. 5 G's plus 4 S's is equal to 26. That's one equation. Here's another one. Same thing. 3 G's, 2 S's, 15. Okay. 3 G's plus 2 S's is equal to $15. Now, these are not the same. These are not the same. I cannot just add or subtract and get them to cancel, but I can make them the same. So this is what I'm going to do. This is called equating the coefficients. I want to make them equal. Either make them both 15 or make them both, 8? You know what? It's easier. Just double this one. Once I double this, this becomes 4s. Oh yeah, that'll be easier. Okay, well, let's go for the easiest one we can. So I'm just going to rewrite them over here. This one I'm going to leave it on. It's just 5G's plus 4S's is equal to 26. Now this is why it's super, and this one I'm going to go times 2. I'm going to double everything. This is why it's super important to have them in the right order, right? So G's have to go underneath G's. Double it, this becomes 6G's plus 4S. There's the equal sign. And it's 15 doubled is 30. Okay, so now that I've equated the S's, right, these, you can see these are equal. They're both 4S, right? So, oh, come back. Come back. Where did it go? There. Once I've got these equal, do I add them or subtract them? Well, if they're equal, you want to subtract. Sometimes you'll get them with like -4 and +4. In that case, you would add because it'd be easier. Okay, 5 minus 6 is -1G. And 0, 0. That's just 0. 26 minus 30 is -4. So in other words, -G is equal to -4. I'm really just going to go divide by -1. Just switch both sides. That means G is equal to +4. You just figured out the cost of a game. Games, 4. Okay, now, how do I figure out the songs? I could start over, but you know what? The easiest thing is to kind of backtrack to one of these equations and plug it in. This one, or this one, or this one. Or go to the easiest one. This was the easiest one we had, I think. It had the smallest numbers. Now, it should work in either one, right? If I was to take 4 and plug it in here, 12. 12 plus 2s is equal to 15. I'm going to get, I think it's 1.5. It should work. You know what? I'm actually going to plug it into the other one just to show you that it'll work in either one. So I'm going to sub back in. So sub back in. So let's do it to this one. 5G's plus 4S's is 26. 5G's plus 4S equals 26. Now G is 12, right? Sorry, G is 4. So 5 times G. So 5 times 4, which is 20, plus 4S is 26. Subtract off 20, I get 4S is equal to 6. When I go divide by 4, 3 over 2, this is 1.5. Okay, so it's $1.50. So the songs cost $1.50. Yeah, so write them in elimination. There, we just did this by elimination. There's my other answer. Q or G is equal to this, S is equal to that, and one song, one game. You know what? I should probably do a quick little check. Okay, so the check is not all that hard. Check, I'm just going to go to this initial equation. 5G's, 4S's, make sure it makes 26. 5G's, 4S's, is it equal to 26? I don't know. Let's find out. Games are 4. So this is 5 times 4, and 4 times 1.5. So 20 plus 6. Yes, it works. Where's the other one? 3G's and 2 S's. 3G's plus 2 S's is equal to, what was it, 15? Equal to 15. Okay, so 3 times 4 and 2 times 1.5 is going to give me 12 plus 3, which that is 15. Yes, it is. It works. Okay, so one game, or so one song, one game, $4 and $1.50. So here's the steps we're doing for elimination. Really what we're doing is we're choosing a variable to eliminate. Like in this case, we got rid of the S's. Why? Because they're really close together, right? Double this one and they become the same. See, once they're the same, S, S. Then I can cancel them out. And because I subtract and 4S take away 4S is 0. That's what you want. You want to eliminate one of them. So here's what we did. My first step, I choose a variable to eliminate. So which one do you want to get rid of? Then what I do is I multiply either one of the equations or maybe both the equations. So I multiply the equation, or maybe it's both of them. But in this last one, I only had to do it to one, right? I only had to double this one because then that became a 4s, right? So multiply one equation or both equations on both sides in order to make the variables the same. So multiply the equations by a constant and it's called equating the coefficients. You make them equal to equate the coefficients. Right? Remember the coefficient is the number out front, right? The variable is s, 4 is the coefficient. This is a 4, that's a 2. I want to equate them. I want to make them both 4, so I doubled this one. This one I left it alone, right? That one's okay. Okay, once you do that, then you're going to subtract if they're the same, or you could add if you have them as opposites, right? If you had negative 4s and positive 4s, I would add them together. You're going to subtract in order to eliminate. Okay, once you eliminate one of the variables, then you can solve for a variable, one of them. Variable, I need to be able to spell. Variable. And once you solve for one, instead of going through this whole process again, just sub it back in to figure the other. Okay, sub back into easiest equation. Look for the easiest one. Back into equation for the other variable. Other variable. Okay, so let's solve this one by elimination. Yikes, look at this beast. I am not going to be graphing these. These are too ugly to graph. And besides, I can't do it very accurately. And if I try and solve for y equals or x equals, look at all these fractions. Look at how hideous things are. This is not going to be an easy one to do by substitution. But here's the idea. If I could make the y's the same, I could cancel them out. Or if I could make the x's the same, I could cancel them out. Okay, step one. Let's get rid of some of these fractions. This one has a denominator of 6. This one has a denominator of 3. I'm going to multiply both sides by 6. Because watch, when I multiply by 6, this becomes 5y. Really think about it. It's 6 times 5, 30 over 6, right? Because I'm multiplying by 6 over 1. I'm not multiplying the bottom. Yeah, so I know that when I do that, that becomes 5. So this becomes 5y. When I multiply by 6 over here, 6 times 1 is 6. 2/3 times 6. So 2/3 times 6 is really 12/3, which is 4. Okay, so this is the exact same equation, but with better numbers, no fractions. Okay, I like it better with no fractions. Now what? Over here, what are we going to times this one by? I'm going to times everything by 3. Denominator 3, denominator 3. Okay, so times by 3. I'm going to get 3 over 3, or in other words, 1x plus 3 times 4. 3 is going to cancel. 4y plus 5 is equal to 0. Okay, there we go. No fractions. Now, you know what? At this stage, I could have said, hey, look, there's an x. I could solve for x equals and substitute it in. But we'll do it by elimination. Now, notice this is kind of messed up because they're not in the same order. This one goes y equals number and x. This one is x number, or xy number. This one's kind of like general form. I kind of like this where it goes x's and y's equal to some number. So watch. I'm going to move this over. X plus 4y is equal to minus 5 minus 5, negative 5. And in the same way, I've got x's and y's on opposite sides. What if I go plus 4x to both sides? So in other words, if I move this one over here, look what I get. I get 4x plus 5y is equal to 6. Okay, so I've got x's, y's equal to number. X's, y's equal to numbers. Okay, so they're in the same order. So now I'm kind of ready. I can either get rid of the x's or the y's or whatever. I want to choose a variable I want to eliminate. 1x, 4x. That's an easy one. If I times this by 4, then I've equated the x's. If I wanted to do it for the y's, 5y and 4y, I got to make them both 20. So this one times 5, this one by... let's get rid of the x's. So here's what we're going to do. This one I'm just going to leave it alone. 4x plus 5y is equal to 6. Leave it alone. This one I'm going to go times 4. What? I'm going to multiply everything by 4 because this will become a 4x. And I'm going to put it right underneath. 4x, 4 times y, plus 16y is equal to 4 times negative 5 is negative 20. Okay, I've lined them up, the equal signs, the numbers, the y's, the x's. Now I can subtract because 4x minus 4x is 0. I've just eliminated the x's. Fantastic. 5y minus 16 is minus 11 y's. And 6 minus minus 20, think about it, minus minus 20 is positive 26. Okay, so hang on. Have I done this right? You know what? This isn't going to work out. Look, I made a mistake way back up here. Let's go back and fix it. Okay, 3 times 5 is not 5, it's 15. So this is not minus 5, it's minus 15. When I bring it over, it becomes plus, oh no, I multiplied this by 4. So what's 15 times 4? This shouldn't be 15. What should this one be here? This should be 4, 16. This should be times 4. This should be minus 60. Oh, that's what it is. So it's 6 minus minus 60. This becomes 66. Ah, there it is. Whew. Good thing I've caught that because now when I divide, let's see what I get. Divide by negative 11, negative 11. Y is equal to negative 6. Ta-da! There's my first answer. Now, how do I figure out what x is? I'm simply going to go back and substitute it into any equation. Now, there's some people who say, oh, you have to plug it into the original one. Look at how ugly those are. You know what? I'm going to plug it into the simplified version. Because remember, the first thing I did was I multiplied by 6. And it made an easier equation. I multiplied this by 3. Makes this an easier equation. This has got bigger numbers. Let's go to this one. So I'm going to substitute it back into this. Okay? So 5y is equal to 6 minus 4x. 5y is equal to 6 minus 4x, and I know what y is. Y is negative 6. Okay, so 5 times negative 6 is negative 30, is equal to 6 minus 4x. Now it's just a matter of solving. I'm going to add 4x over here, plus 4x. Here's what I get. I get 4x minus 30 is equal to 6. Add 30, add 30. 4x is equal to 36. There we go. X is equal to 9. Ta-da! So there's my answer. Y is equal to negative 6, x is equal to 9, and I avoided all these fractions. It's kind of nice. So some people like elimination because it will avoid the fractions, right? Now, if I was to do a check for this one, maybe we should do a quick little check. It's not that bad. You have to start with the original equation. You got to start because it's got to work in the original one. Oh, man. I know this is the answer. So you know what? I'm just going to do one of these checks. Let's do 5/6 of y is equal to 1 minus 2/3 of x. Yikes. 5/6 of y is equal to 1 minus 2/3 of x. What was y? Y was negative 6. So 5/6 of negative 6. Okay, that's actually nice. This is 1 minus 2/3. What is x? X is 9. Oh yeah, this one's nice as well. So the 6 is canceled. This becomes negative 30 over 6. This is negative 5 is equal to 1 minus, now 2/3 times 9, 2/3 times 9, 2 times 9 is 18/3, which is 6. Guess what? It works. Oh yeah, negative 5 is 1 minus 6. Yep, negative 5 is equal to negative 5. It does work. To check it in the other one, the other one's going to work as well. Look, if I take 9, plug it in, I'm going to get 3 plus 4/3 of y. 4/3 of y is 4/3 of 6. Hang on, think about it. 4/3 times 6 is 24/3, is 8. So negative 8 plus 5. So 3 minus 8 plus 5, does that equal 0? Yes, it does. That's minus 5 plus, it does work. I'm too lazy to do it out right now. Okay. Let's get into the last one, and then we're done with these notes. It says, during lunch, the cafeteria sold a total of 160 muffins and individual yogurts. The price of each muffin is $1.50. Yogurts cost $2. Now it says the cafeteria collected $273.50. Set up and solve a linear system to determine the number of muffins and the number of yogurts. I'm not going to be using X and Y here. There's no need to use X and Y. How about we use M for muffins and Y for yogurts? Okay, so I need to define my variables. M is going to be, so what are they looking for? Determine the number of muffins. Number of muffins sold. Okay. And Y, I'm going to call that Y. Y is the number of yogurts. Yogurt. Okay. Number of yogurts sold. Now, it says the price is $1.50 and yogurt's $2. Isn't that the answer? No. What are we looking for? We're looking for the number. We're not looking for the price. Okay. It says a linear system. I know that they made $273. So if we're talking about money, muffins were $1.50. So 1.5 times the number of muffins, and it's a total, right? 273 in total. So I'm going to go this plus this. How much are yogurts? Yogurts are $2. So $2 times the yogurts, that should equal 273.50. Okay. That's one equation. I could move over the M or move over the Y. I don't know what to do here. Now what? It says set up and solve a linear system. System means two equations. I've got one equation. I need a second equation. What's my other equation going to be? Is it $2? No. Is it 273? What have I not used here? It says during lunch, the cafeteria sold a total of 160 muffins and yogurts. That's the number of them. Oh, that's a total number. So we're not talking about how much they cost. We're just talking about the number. I know that M plus Y, oh yeah, there it is. M plus Y must equal 160. Okay, that's actually a nice equation. Remember, that's usually one of the equations when you're setting these up. Usually they'll tell you a total, so it's just something plus something. Now, this one's pretty easy to solve for move over the Y or move over the M. You can substitute one into the other. But let's do it by elimination, because elimination is pretty slick here. It's pretty easy. Watch. 1.5 M's, M's. 2 Y's, Y's. Why don't we just double this one and then we can make the Y's the same. So that's what I'm going to do. I'm going to rewrite these two, but I'm going to multiply this equation by 2. So watch. 1.5 M's plus 2 Y's is equal to 273.50. Double this one. 2 M's, 2 Y's is equal to 320. So 2 M's plus 2 Y's is equal to 320. Now when I subtract, the 2 Y's cancel. Ever notice that we're getting a negative when we do this and we get another negative? Now I know the two negatives are going to cancel, but wouldn't it be easier to just have these written the other way around, right? Because I could have just taken this entire thing here and moved it up top. See, and then I'd have a positive. So I just chose to put this one on the bottom, this one on the top. And it doesn't really matter. You can do it either way you want. But here's another thing to notice, that let's say I know I'm going to get a negative here, and I know I'm going to get a negative here. Nobody says you have to do top minus bottom. You could do bottom minus top. It would still work out the same. What? Crazy talk. Look, 2y minus 2y is still 0. What's 2 subtract 1.5, right? Let's do bottom minus top, because I could have arbitrarily put this one on top. This is going to be 0.5 M's. But I have to do bottom minus top here as well. So 320 take away 273.50 is actually going to give me, hang on, what's 320 take away 273.50? I know it's going to be a positive number, right? 50, this becomes a 9, this becomes a 3, this becomes a 1, that becomes 46.50. So in other words, 0.5 M is equal to 46.50 times 2 on both sides. That's like saying a half, right? Times 2 times 2. This becomes 1 M. This becomes 93. Ta-da! You just figured out what M is. They sold 93 muffins. Okay. Now, how do I figure out what the other one is? Oh, yeah, I have to go back and plug it into an equation. Hello, plug it into the easiest equation you got. There's the easiest one, right? Right there. There it is. Look, the two of them add up to 160. which means the other one's got to be, what is it, 67? Yeah, the other one's got to be 67. It does. Like I didn't even have to show the work for that one because I know it's 160 minus 93. So that means y is equal to 67. So there's my answer. 93 and 67, I should probably do a check. If it's a word problem, yes, we're always going to have to do a check. Now, the check is actually not that bad. Look, check, I know that 93 plus 67 is equal to 160. That was the easy one, right? That's an easy one. The harder one is the numbers. 1.5 times m's. Okay, so let's try it. 1.5 times 93 plus 2y's. 2 times 67. 67. Does that equal 273.50? I think it does. So if, I'm just going to do this on a calculator. Like, okay, 1.5 times 93. This is 139.50. 2 times 67, 120, 130, 134. And when I add those up, it does, yes, it does. It does make 273.50. Okay, so here's something to keep in mind. Elimination might be preferable. So some like elimination over substitution. Why? Because you can avoid fractions, right? Remember this one back up here? If you wanted to do this one with the, even if you get rid of the fractions, if I'm going to solve for x or y, I know I'm going to be dividing by 5 or dividing by 6 or dividing by 4, dividing by 4, dividing by 15. There's going to be lots of fractions. So some people like elimination better as you can avoid fractions if you want, right? Now, if you're comfortable and you like fractions, great. Substitution always works. So sometimes it's a lot easier to avoid the fractions, especially if you're going to be graphing. We're not going to be graphing these things. However, both work. So both elimination and substitution work as algebraic methods. And algebraic, in other words, once you're using algebra, they're exact. There's no guesstimation, no estimation at all. So if a test said, solve this using an algebraic method, you could either use elimination or substitution, your choice. They both work. Okay, and with that, that is the end of chapter 8. We're now done. So the last thing is going to be on Wednesday's date. I'm going to put on a chapter review. And then hopefully, I think on Friday the 12th, I'll send out a test for you guys. It'll be the very, very last test. And it's just on systems, right? There'll probably be maybe 1 or 2 word problems. Nothing huge, but just on all these systems. Alrighty. Good luck with these.